When NASA's Juno spacecraft recently flew over the poles of Jupiter, researchers were astonished, as if they'd never seen a giant planet before. And in a sense, they hadn't. The pictures were unlike anything in the history of planetary exploration. Juno entered orbit on the 4th of July 2016 and later found Jupiter's poles covered in nearly continent-sized storms that are densely clustered and rubbing together in a mind-blowing swirl. It's like a whole new Jupiter, says Scott Bolton, Juno's principal investigator from the Southwest Research Institute. The clouds were amazing. What's striking about Jupiter's polar storms is that there are actually multiple cyclones at each pole. So instead of having one polar vortex like Earth, Jupiter was observed to have as many as 8 giant swirls moving simultaneously on its north pole and as many as 5 on its south pole. Even more amazing things are lurking below. Researchers have long wondered about the giant planet's hidden interior. How far down do Jupiter's continent-sized storms descend? And what is the exotic material near the planet's core? Deep inside Jupiter, high temperatures and crushing pressures transform Jupiter's copious supplies of gaseous molecular hydrogen into an exotic form of matter known as liquid metallic hydrogen. Think of it as a mashup of atomic nuclei in a sea of electrons freely moving about. Jupiter's powerful magnetic field almost certainly springs from dynamo action in Jupiter's interior, the process by which the motion of this electrically conducting fluid is converted into magnetic energy. The exact location within the interior is a mystery that researchers are still working to solve. A planet's magnetic field gets weaker as you get farther from its core. Jupiter's magnetic field is 10,000 times stronger than that of Earth. However, when measured at the cloud tops, Jupiter's magnetic field is only 20 times greater than what we measure on Earth's surface. This is due to Jupiter being so much larger than Earth. Astronomers have long known that Jupiter has the most intense planetary magnetic field in the solar system. But according to Jack Kernerney, Juno Deputy Principal Investigator at NASA's Goddard Space Flight Center, Juno's magnetometers indicate that Jupiter's magnetic field is even stronger than we thought. Moreover, the magnetic field looks lumpy, he says. It is stronger in some places and weaker in others. This uneven distribution suggests that the field might be generated by dynamo action closer to the surface, above the layer of metallic hydrogen. Jupiter's magnetic field is home to the biggest and most powerful auroras in the solar system. Unlike Earth, which lights up in response to solar activity, Jupiter makes its own auroras. It does this by tapping into power generated by its own spinning magnetic field. Induced electric fields accelerate particles toward Jupiter's poles, where the aurora action takes place. Another source of insight is Juno's microwave radiometer, which measures thermal microwaves radiating from the deep recesses of the planet, revealing structure hundreds of kilometers beneath Jupiter's thick clouds. Recent results from Juno's gravity experiment show that Jupiter's iconic belts and zones rotate as a series of cylinders down to depths of about 3,000 to 5,000 kilometers. Beneath this depth, it appears that Jupiter may be rotating as a rigid body. New discoveries about Jupiter continue to be made. Bolton says, every 53 days Juno goes soaring by Jupiter and gets doused by a fire hose of data. There is always something new.
Everywhere on Earth that there's water, there's life. We have several ocean worlds in our solar system. And by exploring Europa, we're getting a taste of what these ocean worlds are like.
Europa is one of the moons of Jupiter. It's about the same size as our own moon, a little bit smaller, but it's so much different. It's an ice world.
Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
When we first discovered hydrothermal vents on our seafloors on the Earth, we also discovered life. There was no sunlight that was penetrating down that deep, but yet there was life living there.
On Europa, we're not looking for life itself, we're just looking for an environment in which life could thrive.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are very few, shockingly few impact craters. So that means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening.
The Europa Clipper mission will be the first in-depth exploration of an ocean world.
Europa Clipper is orbiting Jupiter, and it's performing 49 flybys of Europa. And the main reason it's doing that is to stay mostly outside of Jupiter's really intense radiation belts.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near infrared, the far infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. We're looking for signs of organics at Europa. Are there materials that contain carbon and hydrogen and oxygen and nitrogen? And we have another instrument that can tell us the composition of dust particles. We're pretty sure there are salts on Europa's surface, and those salts may have come out of the ocean. We want to understand what are those salts.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
Last but not least, we have a gravity experiment using the communication system of the spacecraft, and from that we can get essentially a map of the gravity field.
We can get the shape, understand what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
So there really has not been a mission like Europa Clipper. The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
I have no idea what we are going to detect beneath Europa's icy surface, but all I know is it's going to be wonderful.
We do this work of exploration for the next generation. We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?